When ecologists are looking at different types of organisms, often they'll create something that's called a survivorship curve. And a survivorship curve is a type of graph that shows how a group of individuals, what their survival rates are as they move through time. Okay? From birth to the maximum potential age of that organism. And so the graphs look something like this. Typically on the y-axis we have some measure of survivorship. It might be a percent of individuals that are surviving, or if we're using raw numbers, it might be the number of individuals that survive as their natural lifespan goes on. Often these are also expressed on a logarithmic scale. You can see here we go 1 to 10, then 10 to 100. Same thing on this side. We go 0 to 1, 1 to 10, 10 to 100, 100 to 1,000. So when we create these types of graphs in class, we're going to use a log scale on the y-axis. And what we see when we look at the survivorship of different species over time is that they may exhibit sort of three different types, and we call them type 1 and type 2 and type 3 survivorship curves. So we can look at these two, type 1 survivorship curves. And if we think about what this data is telling us, what is this the shape of this line telling us? It's telling us that in the early stages of life, a large percent of individuals are able to survive the early stages of life. And as time goes on, as they get closer and closer to the maximum lifespan, that is when the majority of individuals start to die off. And so it has this shape. This is typical of case-selected species. If we think of these elephants, most elephants are able to survive birth and survive into adulthood, and then they tend to die later in their lifespan. So these are typically case-selected species. Type 2 survivorship in this line that we see here basically means that individuals die at a relatively uniform constant rate. It's just sort of a straight line from early birth to adulthood and to maturity and beyond. And so what we see is a relatively constant survivorship here. And then in a type 3 survivorship curve, we see here, let's look at what is the data telling us. It's telling us that in the early stages of life, a large percentage of individuals do not survive. Okay? Only a few individuals survive and reach adulthood. Once they do make it to adulthood, then they typically, many of them would live out their full lifespan, but there's this rapid die-off in the early stages of life. Insects would be an example of this, or dandelions like we saw earlier, or frogs and the tadpoles. Many of those tadpoles, if a frog lays thousands of eggs and they get fertilized, the vast majority of them do not survive into adulthood. Only a small percent do. And that's what the type 3 survivorship curve shows us. It shows us, and this is typical of our selected species, that many of the offspring don't survive, but the ones that do can typically live out their lifespan. And so these are the three types of survivorship curves, type 1, type 2, and type 3. And one thing to note, these graphs, these curves, they can never go up. Because if you imagine this type 3, if the percent of individuals that survive after a year, for example, is 10%, well, then you can't have 11% or 15 or 20%, because this is a percent of the original number of organisms. So it can never go up. It's constantly declining.